Hello friends, continuing with scientific method. Today we take up discovery of modern atomic theory. Let us look at ancient Indian view of matter. Matter is composed of 5 elements according to ancient Indian view. Number 1 earth, number 2 water, number 3 fire, number 4 air, and number 5 space. Kannada and Democritus view of matter. Matter is composed of Paramanus. Paramanu is a Sanskrit word. In English we call it as atoms. Matter is composed of Paramanus, which are tiny invisible particles. Now we look at ancient Greece view of matter. Number 1, according to this view, matter is composed of tiny invisible particles and they called them as atoms. Number 2, matter could be a continuous or discontinuous arrays of these atoms. Number 3, size of an atom is smaller than the smallest visible particle, even smaller than the wavelength of light in the visible region. Number 4, atoms of one substance could differ than that of other substance in shape, size, and properties. Number 5, new substances can be produced by the combination of atoms of different substances. Now this was ancient Greece view of matter and it was without any proof. Then came John Dalton's atomic theory, whose postulates are as follows. It was the time period 1908 when he proposed this theory. Number 1, matter is composed of tiny invisible particles. Number 2, all atoms of an element are same in shape, size, and weight. Number 3, atoms can neither be created nor can be destroyed. Number 4, atom is the smallest unit that takes part in chemical reaction. And number 5, atoms of different elements combine in simple whole number ratios to form compounds. This theory was modified after discovery of isotopes and isobars. Then came modern atomic theory, whose postulates are as follows. Number 1, atom is no longer an indivisible particle. It consists of electrons, neutrons, and protons. However, in a chemical reaction, an atom takes part as the smallest particle. Second postulate, atoms of the same element may not be identical. We are familiar with the discovery of isotopes now. So after discovery of isotopes, this postulate came, atoms of the same element may not be identical. Number 3, atoms of different elements may have same mass, isobars, after discovery of isobars. So this postulate came, atoms of different elements may have same mass. Number 4, an atom may not be capable of independent existence but exist in a molecule. Number 5, atoms of an element can be altered. And this way this theory progressed. Now you have to answer these 4 questions. Explain briefly ancient Indian view of matter. Question number 21. Explain briefly ancient Greece view of matter. Question number 22. State postulates of John Dalton's atomic theory. Question number 23. State postulates of modern atomic theory. Now we continue with it. Now how discovery of present day atomic model was made. Now discovery of present day atomic model. Matter is electrically neutral. Because atom is electrically neutral, had been the established fact by that time, with the information that number of electrons is equal to number of protons in an atom. How electrons and protons were distributed was not known, and various models were proposed. The proposed model had been number 1, J.J. Thomson model of atom, Rutherford's model of atom, Bohr's model of atom, Sommerfeld's model of atom, Ehlenbeck's model of atom, and so on. So this way the discovery of present day atomic model had been made. Now let us look at them one by one. First we take up J.J. Thomson model of atom. Now the postulates of J.J. Thomson model of atom were: first, the positive charge is distributed uniformly over whole of the atom, and negatively charged electrons are embedded into it like seeds in a watermelon. So this was the postulate given by J.J. Thomson model of atom, that the positive charge is distributed uniformly over whole of the atom, and negatively charged electrons are embedded into it like seeds in a watermelon. Here you can see red part is the positive charge and black spots are the electrons which are embedded into it, just like watermelon. Now what was the discrepancy of this model? Exact location of the charges were not known. What? Exact location of the charges were not known. And second discrepancy was that the slight perturbation would cause electrons to vibrate about their mean positions, and atom will become unstable. So what was the second discrepancy? Slight perturbations would cause electrons to vibrate about their mean positions, and atom will become unstable. Now this difficulty was overcome by Rutherford's model of an atom. What was Rutherford model of an atom? Based on his famous alpha particle scattering experiment, he gave the nuclear model of the atom, whose postulates were: he said the whole of the positive charge is concentrated at the center of the atom, called as nucleus, and electrons are revolving around the nucleus. So he gave the exact location of positive charge and negative charge. He overcame the difficulty of J.J. Thomson's model by doing alpha particle scattering experiment. Now what were the difficulties with Rutherford model? Now difficulties with Rutherford model had been, though location of positive charge is known, yet locations of electrons is not known, is not certain. And second, electrons would radiate out energy and slowly, spirally would fall into the nucleus and system would vanish. The Rutherford model was also unstable. The Rutherford model was also unstable. Now, to overcome the difficulty of Rutherford model, Bohr's model of atom was proposed. Bohr proposed the model whose postulates were as follows. Number one, first postulate, electrons, he said, electrons are revolving around the nucleus in stationary orbits in which electrostatic force of attraction is balanced by the centrifugal force. That is, K naught Z E square by R square is equal to mv square upon R. Second postulate. In second postulate, he said, stationary orbits are those in which angular momentum of electrons is equal to integral multiple of h by 2 pi. That is, mathematically we write it as mvr is equal to n into h by 2 pi, where n is integral. And the third postulate he gave, energy is radiated or absorbed is equal to the energy difference between initial and final orbit when an electron jumps from higher to lower or lower to higher orbit respectively, and this difference is equal to h nu always. That is, delta E is equal to h nu. And this way he overcame the difficulties of a Rutherford model. Now then came Sommerfeld. Sommerfeld model of an atom was proposed in 1915. He calculated the radius of the circular orbits of the atom, and he found that orbit is not circular but is elliptical. So Sommerfeld made the Bohr's circular orbit elliptical. And then vector model of an atom came. Allenbeck introduced spin to electrons, then with Goudsmit concluded that elliptical orbit is not fixed but is quantized in space. So it can assume any shape, any position around the nucleus. So this way the present day model progressed. Now some questions, assignment. Now state postulates of J.J. Thomson atomic model. What had been the discrepancies of this model? Question number 25. How discrepancies in Thomson model was overcome by Rutherford's? State postulates of Rutherford model of atom. What had been the discrepancies of this model? Question number 26. How discrepancies of Rutherford model were overcome by Bohr? State these postulates of Bohr's atomic model. Question number 27. Give contribution of Sommerfeld, Allenbeck and Goudsmit to present day atomic model. Question number 28. Draw diagram of logo of International Atomic Energy Agency of UN located in Austria. So this way you are to answer the questions what you have gone through previously. So I hope you will be able to answer these questions. Now you see how in discovery of present day atomic model scientific method has been used. You see how slowly the discrepancies were removed by having critical observations about the what have been stated by the previous scientist, right from J.J. Thomson to Rutherford to Bohr to Sommerfeld and to Allenbeck and Goudsmit. This way they have been able to give us the present day model of an atom. And it is only through scientific method. They made observations, critical observations, they argued, they gave logical reasoning, and then they prepared models and then theoretically predicted the present state. So this is how scientific method is so important. So here we conclude with scientific method. Now every scientist followed scientific method and noticed discrepancies in the then existing theories and modified them. These steps are observations, logical reasoning, model making, and theoretical predictions. Now a tribute to the scientists who made such contributions. So with these presentation, we pay our tribute to all those scientists who gifted us the present body of knowledge through their continuous efforts, perseverance, and research, without which present day comfortable life would not have been possible. Thank you and have a nice day. Best wishes from me. Thank you so much. I hope you would have enjoyed the scientific method, explanations of scientific method given to you in various parts, right from first to fifth part. I hope you have enjoyed it. Okay, God bless you.